This video is going to talk about different shifts in graphs and how they can move on the coordinate plane. That's section 2.2 for college algebra. On your graphing calculator, you can put graphs in. So this right here is the y equals button. If you hit that button, then you can enter graphs. If you hit clear, which is over here on the right, that'll get rid of those equations that are in there. And then we're going to type these. So your X button is right next to the green alpha button. And then X squared is right here. So that's how you can type X squared. Then if you arrow down, let's see, I'll match the colors. Y2 is going to be X squared plus 3. Arrow down, you got X squared minus 2. And then arrow down again, and we've got X squared minus 5. The colors don't matter. I'm just making mine match so that when you see the graph, you'll see what it looks like. So if you hit graph, you might be able to see them. But if you look, my range is really big, like negative 150. So I'm going to hit the zoom button, which is the top middle. And then I'm going to go to 6, zoom standard. And that'll bring us to a 10 by 10 graph. Now I can see the difference in the curves. So what do you notice? Compare the colors to the equations and see what you see. So the blue one is called our parent function. That is the basic function. Nothing happened to it. Oops, I don't know what I just did. Nothing happened to it. It's this function right here, the blue one. The red was plus 3. And if you look at the red on the graph, it's at the top. And then the green was minus 2, so it's down here. And I actually typed the pink one wrong, so I'm going to go back to y equals. I typed minus where the equation says plus. So let's look at what happens if I change that to the right thing. Now the pink's on top. So if you put all that together, what do you see? Well, if you add something to the parent function, it moves up. And if you subtract something from the parent function, it moves down. So this is away from the x. This is outside of parentheses. If there's parentheses, they move them up and down. So let's look at this. The parent function is going to be the red one. So that's this one right here. The parent function is absolute value of x. That was one of our ones from 2.1. Then if we look at this blue one, it's up 2. There's a little 2 right here that you can see. So if our translation is up 2, we can write that as absolute value of x plus 2. And then using function notation, we can just say g of x to show that it's a different function. It's just a different letter. You can use whatever letter you want. That way, if you don't see the colors, you can tell the difference with the f and the g. So those are vertical shifts, up and down. Horizontal, left and right, are going to be inside the parentheses. So that means if it's a square root, it's inside the square root. If it's absolute value, it's inside the absolute value. If it's a line, it's inside the parentheses. If it's quadratic, it's inside the parentheses. So anything inside is telling you left and right. And you always do the opposite. So if it says plus, you're really going to move to the left. And if it says minus, you're really going to move to the right. So let's look at these. Our parent functions are red. That's going to be the square root. The translation went right 1, 2. So right tells us to put minus inside. So g of x is going to be minus 2. And you can put parentheses. You don't have to. That's completely up to you. But that's how those will show up. Now, many equations have both. So your horizontal is going to be inside either parentheses, brackets, absolute value, square root. And then the vertical shift is outside. So when it says to describe, you're just putting it in words. So what does each number tell you? Well, plus 2 inside tells us we're going left. So this one would move left 2. And then the minus 6 outside of the absolute value tells us down. So that would be the movement. The original function is one place, and then it goes left 2, down 6. So all of the points would move that. Pause the video and try B. This tells us we're going right, and this tells us we're going up. So right 2, up 8. All right. Those shifts can affect the domain and range. So let's look at these here. So A, we're going to call this A. F of X is going to be the red one. So the coordinates of this, or there's the red one, this is the equation right here. So the parent function is that same one without any any numbers. So that would be x squared. That squared tells us is x squared. The domain of x squared, if you use our function capsules, is negative infinity to infinity. If we look at the red one here, it still has arrows on both ends. Nothing's changed in that way, so it's negative infinity to infinity. The parent function, and I'll draw it here so you guys can see it. How about I draw it in black? So our parent function would look like this. The range starts at 0 and goes up, so it's 0 to infinity. The range of the red one, it bottoms out at 2. So when our range had a number, by moving it up over here, that changes our range. So that is A, that's the red one. Now let's look at G of X here, which we'll call B. It's going to be the green one. There's that one. The black is going to be what the parent function looks like. So the domain of the black line is 0 to negative infinity to infinity. And the green is the same. It goes up forever, it goes down forever. And then because it doesn't bottom out or top out, the range is also the same. So even though we've shifted it, those don't change because they were already negative infinity to infinity. So your domain and range only are affected if they weren't negative infinity to begin with. So you try C, you try H of X, this blue one here. The original parent function looks like this. I'll do it in black. You try that one, pause the video, and then check in. All right, so the parent domain is the black one. It starts at 0 and goes up forever. The blue one starts at 2 and goes up forever. So notice the opposite of the negative 2 is the positive 2. Now we look at our range. That parent one is also 0 to infinity. So because there's a number other than infinity, we would expect it to change. It bottoms out at negative 3. So our range is negative 3 to infinity, which we can also see in our equation. So that is how the domain and a range are affected. You can go look at the graph. You can look at the equation. It's up to you what's easier. Sorry about the bells. All right. The monthly active Facebook users, F, in millions from 2009 to 2013 is given by this equation. F of X equals 233X plus 200, where X is years after 2009. So that means 2009, X would be 0. 2010, X would be 1, and so on and so forth. That's what that last statement means. So evaluate F of 2. That just means plug 2 into the equation. So 233 times 2 plus 200. If I do that in, 233 times 2 plus 200 is 666. So interpret, the 2 means 2 years. So 2 years after 2009 is 2011. And then F in millions is Facebook users. So there were 666 million Facebook users. That's the interpretation. All right. Use the formula to write an equation that gives you the monthly users, this should say users, during the actual year. So instead of having X represent 0, we want to be able to just plug in the regular year. So we're going to use point slope form. This is something to pay attention to. You're going to see it again. Nothing's really changing. Our slope is still the same, 233. Our X is still the same. And our y-intercept is still the same. The difference is, if we're going to be plugging in 2009 instead of 0, we need to take that away so that we get the same answer. So if we plugged in 2011, if we subtracted 2009, that would be like plugging in 2. So essentially, if you're changing these equations so that they're the actual year that you plug in, you're just going to subtract the starting year from up here. That's all you do. Now we have an equation. So it's still f of x. That part hasn't changed. We're still solving for the same letters. All we did was, now that we've done the minus 2009, we can plug in the year. So if I do that, 2011, minus 2009 plus 200 gives us the same number if you type that in the calculator. So that shows us that that equation works. Now it's saying use B, so we're going to use the equation we made here to find when there will be 1 billion users. And then it gives us a hint that 1 billion is 1,000 million. And we need that because our numbers are in millions. So we would write the equation, 233 x minus 2009 plus 200 equals 1,000 million. So we solve this just like any other algebraic equation, and we subtract 200 from both sides. Then we would want to divide by 233 to get the parentheses alone, which gives us 3.43. Then to undo this subtraction, we would add 2009, and that gives us 2012.4. So 0.4 means it's sometime during that year. So sometime during 2012 is when they would reach 1 billion users, according to this equation. So that is 2.2, to look at how your shifting can affect, and your equation can affect how it looks on a graph. Let me know if you have any questions.